Hello students, in previous videos we have seen Wheatstone bridge and meter bridge. Now in this video we are going to study what is potentiometer and what are their applications or uses. So let's begin. So here in this diagram you can see this circuit. Here is a battery attached, and all here this is the wire, and this small r is internal resistance. What is internal resistance? This means this internal resistance small r is attached with this battery. Means if we are attaching this battery, then this small r resistance is attached with this battery, and the remaining circuit, that is the wire, has the resistance capital R. So this is the resistance of the rest of the circuit. Now what will be the current flowing through this circuit? We know according to Ohm's law, V is equal to I into R, where V is potential difference or voltage, and that is equal to current times the resistance. So if we have to find out the current, what we will do, we will divide it by resistance to this equation. So in this circuit you can see that only epsilon, here this is the potential difference, and the resistance is small r plus capital R, because this is now in the series. So the current capital I through this circuit will be given by epsilon divided by small r plus capital R. So this is the current flowing through this circuit. Now if I have to use again this Ohm's law and want to find out the voltage or the potential difference between any 2 points in this wire, let's say from point A to point B, then what I have to do, I have to multiply this with current, but in this time the resistance is only this much, that is the resistance is R. So I can write the potential difference between point A and B is exactly equal with I into R. I into R. So I is this much quantity and R is resistance. So what will be the VAB? So this is exactly equal to epsilon R divided by small r plus capital R, that is the internal resistance plus external resistance. We can say R is the external resistance. So we get this equation. Now look carefully in this equation. R is the resistance of this circuit A to B, so this will be constant. The small r is the resistance of the battery, or we call it as internal resistance, so this is also constant. So until the epsilon is constant of this circuit, that is the battery, the potential difference is not going to change. Till then the potential difference is not going to change. So suppose if I divide this by L, so I have divided this by L, that is the total length of this circuit, then this will be divided by L. So L is also constant. So what this quantity suggests us, VAB divided by L, or just V by L. So V is the total potential difference through this point A and B, which is the total length of the circuit or of the wire, and this is the length L. So this is the potential difference per unit length, or we will call this as potential gradient. So what is potential gradient, or any gradient means per unit length, so we will call this as potential gradient. So in this circuit, as we have discussed, all these terms in RHS are constant if this epsilon is constant, then if RHS is constant, then LHS must also be constant. L is anyway constant. VAB will be also constant. So the potential gradient or potential per unit length of this circuit is constant. And the principle of potentiometer is that we are using this constant of this circuit. Now we know VAB divided by L is constant. So suppose there is a length A to C and this length is equal to small l, and I know what is the potential gradient or potential per unit length through this circuit. So this is the potential through the circuit. Now this is potential per unit length. So for this L length, what will be the potential? So I have to multiply this with small l. So I will get VAC, that is the potential difference between point A and C, which is equal to L into epsilon R divided by R plus R into L. So in this way we can find out any potential difference or any voltage in between any 2 points in this circuit. So what I want to know, just the length between these 2 points. So if I know the length, then I can find out the potential difference. So in short, we can write the voltage in between any 2 points, let's say A and C, is directly proportional to the length in between this point A and C. No matter whether these points are from A to C, it can be from this point. Let's say this is point D. Let's say this is point D. So if I have to find out CD and this length is also L, then this voltage will be same, because it is only depending on the length between these 2 points. So this is the principle of potentiometer. And in this case, this other constant, except from L, this small l, epsilon R divided by R plus R into L, is shortly can be written as K, which is the constant of this equation. It is written as K.